All right, so the next topic I want to talk about is the substitution and income effects. Now, I kind of hate teaching this, and the reason being is this is one of those things that I think lends itself better to upper level economics courses. And I noticed in your book they don't really do a great job covering it either. They don't really spend a whole lot of time on it. But nonetheless, it's important to understand conceptually, and I might give you a question on it on the final. I'm still trying to decide. But I think I owe it to you guys to cover it a little bit, and if you have questions, just let me know. So let's move on. So the substitution effect is basically, imagine there is a price change, or overall, imagine that there's a price change, right? So let's say you have two goods, pizza and beer, or let's do samosas and beer. Let's stick with that example. So you have samosas and beer, right? And let's say beer becomes relatively more expensive, okay? Well, if beer becomes expensive, like let's say the price of beer goes up, okay? If beer becomes relatively more expensive, well, guess what? First, that's going to hit your budget, okay? So you're able to consume less of both goods overall. And secondly, that's going to change the ratio of beer to samosas that you're consuming. So you would consume relatively more samosas relative to beer. So the way that we capture that is using what's called the substitution and income effects. So the overall theme is that the substitution effect is the switching from beer to samosas, because samosas are now relatively cheaper because the price of beer has gone up. So relative to beer, samosas are now cheaper, whereas beer is now relatively more expensive to samosas. Okay, so that's the substitution effect. The higher the price of beer, when you fix the price of samosas, the more samosas you're going to consume relative to beer. The other side of the thing is that there's the income effect. So the higher the price of beer, the lower overall you can consume. So you're going to consume less beer, but you're also going to consume less samosas by virtue of the income effect. So if you have an increase in the price of beer, so beer is you're definitely going to decrease your consumption of beer, because both the substitution effect will want you to decrease the price of beer and the income effect will want you to decrease the price of beer. But on the other hand, samosas, well, the substitution effect is going to want you to increase the price, the consumption of samosas, because they're relatively less expensive than beer. But the income effect is going to want you to decrease the price of samosas because you have relatively less to spend overall. So a price increase in beer will have a negative effect on beer and an unclear effect on samosas. Okay. Depending on how strong the income how strong the income effect is relative to the substitution effect. So I'm going to break it down graphically and show you exactly how those consumption changes will look graphically. Okay, I'm not going to ask you to calculate any utility change or any income change, but I might ask you to graph different indifference curves and different budget constraints, and show where the income effect is at play and where the substitution effect is at play. And that's all I'll ask you if I ask you a question on the final, which I still have not decided. Okay. So in the event of a price change, you'll see both a substitution and an income effect. Okay. So a price change will decrease, so a price increase of one good will lead to a relative price increase in one good and a relative price decrease in the other good, leading to substitution from the now more expensive good to the now less expensive good. And it will also decrease your overall purchasing power for both goods. Okay. Okay, so if you have beer and samosas, okay, you have different indifference curves. Okay. So, and presume that you like both beer and samosas, such that the indifference curves increase as you go further away from the origin. if this is your first budget constraint, okay, and let's say the price of beer increased, this is your first budget constraint, the optimal bundle will be here, this little yellow line, okay, or yellow dot. That's your optimal budget constraint. How do you know that? Because it's the point at which the budget constraint is indifferent to an indifference, or is tangent to an indifference curve. So it's touching the indifference curve at only one point. Another way of saying that is the marginal rate of substitution for this indifference curve is the same as the price ratio for beer and samosas, and the budget constraint is exhausted. I have cat hair in my mouth. Gross. Okay. So let's say the price of samosas increases. What happens to the budget constraint? Okay, so let's say the budget constraint looked like this. Let's say the budget constraint was 100 equals 10 times beer plus 20 times samosas. And I want to put dollar signs on it so that you know that it's they're prices. So 100 is your income, 10 is the price of beer, $20 is the price of samosas. So if I were to draw that, and S and B, well, I can have 10 beers and 5 samosas. Okay. If I increased the price of samosas to $40, what happens? The x-intercept becomes 2.5, and the y-intercept stays the same. Oh, oof. That's supposed to be a line there. All right, that's better. So the budget constraint moves in. Budget constraint shifts inwards. Okay. So that's going to look like this. You're going to shift the budget constraint inwards. Okay, you can consume the same amount of beer with your money. So same amount of beer, 10 beers, right? If you consume 0 samosas. But now if you consume 0 beers, you can consume at most 2.5 samosas. Also, these are really expensive samosas. Just because I came up with a bad example, but if you're paying $40 for samosa, you are doing something wrong, or those are some bomb-ass samosas. Okay, so what's the new optimal budget or optimal bundle consumption? The optimal consumption bundle. Oof. It's going to be this point right here. Okay, so this is the new point at which the indifference curve is tangent to the new budget constraint. Okay, so you're on a lower indifference curve because you consume relatively less of both goods. And it looks like you're consuming more beer and less samosas. Okay, so let me draw this over yonder. So if I have this here, and then I have a parallel budget constraint here, and I'm going to call this point A, this point B, and apologize for the bad handwriting. At this point, I'm sure you expect it, but you'll see a better graph in the slides. Okay, so moving from budget constraint 1 to budget constraint 2 shifts inwards. That means the new optimal consumption bundle is on a lower indifference curve. Okay. Optimal consumption bundle B. So the new optimal consumption bundle is B. And what happened? So overall, increased beers, decreased samosas. Decreased my Sammy Sosas. All right, so I decreased, so it looks like B is higher than A on the y-axis, but it's definitely lower on the x-axis. So I consume less samosas, but relatively more beer. So why did I increase beer? Increased beer because the income effect was lower than the substitution effect. All right, aka the relative price change matters more here than the overall budget hit that I take. Okay, so I'm consuming more beers, consuming less samosas. If I had a particular shape of indifference curve, it could be the case that I'm consuming a little bit less samosas, such that my overall budget, even though I'm consuming less samosas, my overall budget is still being hit by a lot by the price change, such that I have to drop my consumption of beer as well. So that would be an income effect. In this case, the substitution effect, the fact that beers are much cheaper than samosas after the price change, matters more. Okay, and it's not always going to be the case. Sometimes the one effect will dominate, sometimes the other effect will dominate. It's just the way that I drew it. So if this graph were a lot flatter, then it could be the case that that I'd be like somewhere here, okay, where my overall beer consumption is decreasing as well as my overall samosa consumption. Okay. Okay. So this is the new optimal bundle here. Okay. Now let's say I wanted to decompose the substitution from the income effect. I want to see what the relative price change matters without worrying about income. Okay. So this is a parallel budget constraint to the new bundle. Okay. So basically this is saying, what if we keep the price ratio steady? We keep the ratio of the price of beer and the price of samosas equal to what they were after the price change. Okay. But we keep our income level the same. Okay. So fix income at $100. I'm sorry. We increase the overall income level, but we keep the price ratio the same, such that you can still operate on this indifference curve. Okay. So basically, what I'm looking for is this point here. Okay, where it's tangent to the old indifference curve. Let me be a little more clear. I want to find the substitution effect. I want to keep the PX, the new price ratio, constant. So P beer divided by P samosas, aka $10 divided by $40. So I want to keep the same slope. I want a parallel line to the new budget constraint. Parallel line to the new budget constraint. Okay. And I want that parallel line to be tangent to the old indifference curve. AKA substitution effect new price ratio old indifference curve. So essentially we're looking for when the old indifference curve had the same marginal utility as this one here. Okay. This will get the amount of consumption change that is, how did my mouse go over there? That results only from the price ratio change, the change in relative prices. Right, so I said that a substitution effect is what happens when the price of one good becomes more expensive or less expensive. So it changes the relative prices of one good to another. And then the income effect changes the overall purchasing power. So if I just want the relative prices without worrying about the overall purchasing power, what I can do is I can take the budget constraint and keep the price ratio steady. So take the new budget constraint, keep the price ratio steady, and draw a parallel budget constraint. I'm not actually, yeah, I can do that. Oh, hey. Oh, All right, good enough. So A is the old. No, I want to leave it there. No, I don't. Sorry. Come on. All right, I guess I'm leaving it there. Fate and happenstance. Oh my gosh. Why is it being so difficult right now? Perfect. Okay. So basically what I want to do is I want to take this and move it over here. So have it parallel to the old budget constraint, but tangent to the old, have a parallel to the new indifference curve. So let's call this IC1. Let's call this BC1 and call this BC2, and then I want this to be BC sub effect. Okay, so I want a parallel, so BC sub effect is parallel, same slope, aka same price ratio px divided by py to BC2, new budget constraint, but tangent to IC1. Okay. So then I'll draw point point C. Okay. Point C is the optimal consumption bundle if IC1 and BC2 or BC sub effect, I should say, for IC1 and BC sub effect. Okay. The move from A to C is my substitution effect. Okay. This answers what happens if I can consume what happens if I have to consume at a different price ratio, but for the same indifference curve. Okay. So A to C is my substitution effect. I would highlight that if I could. Maybe I can. There you go. A to C is my substitution effect. Okay. So by virtue of just substitution, I have less samosas because they're more expensive, and I have more beer, okay, because they're relatively less expensive. Oh, sorry, I jumped the gun a little bit. Where's my mouse? I want to go back to whiteboard. All right, so actually, let's stop there before I move into the income effect. So the overall point is, if I consume moving from A to C, that's my substitution effect. Let's not stop, actually. Sorry. I just want to knock these out. So the move from C to B then is what's left, okay? So now that we know the sub effect, the move from C to B is our income effect, okay? So basically, the income effect answers what happens when I am forced to consume for lower purchasing with lower purchasing power. Okay, so we're moving down the budget constraint to the actual budget constraint BC2. Okay. So BC2 2 is less than BC1 and BC sub effect. So the move from C to B captures the move from BC sub effect to BC2. Okay, so you're on a lower indifference curve now with the same price ratio. So that'll decrease both the beers consumed and the samosas consumed relative to the point on the, we'll call it the counterfactual BC sub effect. Okay. So it's basically so BC sub effect is like the counterfactual budget constraint you would need to stay on the same indifference curve. So if we just brought it back inwards, we're decreasing the overall relative purchasing power. Let me write this down. Or maybe I guess I did. AKA we are moving from a higher budget constraint with same price ratio to a lower budget constraint BC2 that is the actual purchasing power that we have, aka it's the actual budget constraint we have. All right, so the overall income effect would just be moving the budget constraint in from the counterfactual budget constraint to the real budget constraint and seeing the drop in both goods. Whereas the substitution effect, you draw the counterfactual budget constraint, stay on the same indifference curve, and see the relative increase in one good, the good that became less expensive, and the relative decrease in the other good that became more expensive. I think that's it for these. Oh, yeah, sorry. So when price decreases, okay, consumer purchasing power increases, right? So the overall budget constraint will shift outwards, okay? The income effect causes the quantity demanded to increase if a normal good and decrease if an inferior good. The substitution effect causes the opportunity cost of consuming a good to decrease when the price decreases, which causes the quantity demanded of the good to increase. And flip it around for the other one. Yeah. All right. I'll move into the last piece of the lecture now.